For years, one open-source project quietly held the internet together, the tool almost every app uses to move data across the network. This year, its maintainer shut down the reward program that paid people to report security bugs in it. Not because the bugs dried up, because he was drowning in fake ones, a flood of AI-written vulnerability reports, confident, well-formatted, and wrong, that cost more to disprove than they were ever worth. So here is the twist that makes this story worth telling. The same kind of AI that buried him in noise is now being sold as the cure. In late July, OpenAI open-sourced a security tool built on an agent that reads your code line by line the way a human researcher would. This video is about how that machine actually works, and whether an AI can be trusted to hunt the bugs that other AI keeps inventing. To see what is new, remember the old way. Our last video took apart the classic code scanner, the kind built into GitHub. It does something clever and narrow. It turns your code into a searchable database of facts, then traces a piece of untrusted input from where it enters to a dangerous place it should never reach, a database query, a shell command. If that path exists with no cleaning step in between, it rings an alarm. It is fast, it runs on your own machine, and it never gets tired. But it only ever answers one question: did the tainted data reach the sink? It cannot tell you whether the lock on the door actually works. It can only tell you the data got to the door. And that gap is exactly where the hardest bugs live. OpenAI's own engineers put it sharply. There is a big difference between the code calls a sanitizer and the system is actually safe. Their example is beautiful in how ordinary it is. A web server checks an address against a list of allowed ones, then decodes it. Do those two steps in that order, and an attacker hides a forbidden address inside encoded characters that slip past the check and only reveal themselves after. Every individual line looks correct. The data flow looks clean. A traditional scanner sees nothing wrong because nothing is wrong at the level it inspects. The flaw is in the order of operations. The wrong assumption, the moment the system is quietly in a state its own author never intended. To catch that, you cannot just trace data. You have to understand what the code is trying to guarantee, and notice that it does not. Which is what this new tool attempts. It began inside OpenAI under the codename Aardvark, became a product called Codex Security, and in late July its command line version was released as open source. And it works in a way the old scanner never did. OpenAI describes it plainly. It does not rely on traditional techniques like fuzzing or scanning your list of dependencies. Instead, it reads code the way a human security researcher might. Reading, reasoning, writing tests, running tools. It is not a database query. It is a language model pointed at your repository, told to go find the ways it can break. So walk the pipeline, because this is the actual machine. First, it does not jump straight to hunting bugs. It reads the whole project and writes a threat model, a document describing what this system is trying to protect and how it is supposed to defend itself. It is deciding what safe even means here before it looks for unsafe. Second, the scan itself, and this is the part you can verify because the harness is open source. It does not sample the code or guess at the risky parts. A bundled instruction file tells the agent, in plain English, to list every file in scope and review every one from start to finish, and, in its own words, do not stop reviewing a file after finding one bug. It reads everything, the way a patient human never could. Then comes the step that separates this from a machine that just spouts suspicions. For every candidate bug, the agent is told not to trust its own reasoning, but to prove it. It tries to build a working exploit in a sealed sandbox, compile a special instrumented build of the program that trips on bad memory, write a tiny targeted fuzzer aimed at just that slice of code, even hand the problem to a mathematical solver to work out the exact input that breaks it. Only if it genuinely cannot build a proof after real effort is it allowed to fall back on, I read the code and I think this is wrong. Stop and notice why that whole apparatus exists. It exists because the model, left alone, over-reports, it makes things up, it sees bugs that are not there. The sandbox, the proof, the fuzzer, that is not decoration. It is the machine admitting that a language model's confident opinion is worth nothing until something outside the model confirms it. And when a finding survives all of that, it does not arrive as a naked alert. It comes with two separate numbers, and keeping them separate is the entire point. One is severity, how bad this would be if it is real. The other is confidence, how sure the tool is that it is real at all. A traditional scanner blurs these together into one undifferentiated pile of red, which is precisely what buries a maintainer. By splitting them, the tool can say, in effect, this one is catastrophic and I am certain, act now, versus this one is worrying. But I am guessing, glance at it when you can. That is the whole promise. Not more alerts, but alerts a human can triage in the order that a human would. So does it work? The honest answer is yes, and with an asterisk you must hear. On the yes side, this is not a demo. Pointed at real, serious open source projects, this tool has found genuine, dangerous flaws. Memory corruption bugs in security libraries. An authentication bypass. 14 of its findings were serious enough to be assigned official vulnerability identifiers. The industry's way of saying this was real and it mattered. On a curated test set, it caught around 92% of the planted bugs. But hold that number carefully. Those were known bugs, some of them deliberately injected in the maker's own hand-picked repositories. It measures how many of the bugs it was looking for it managed to find. It says almost nothing about the novel bugs in your code that nobody has thought of yet. Scoring high on an exam where you helped write the questions is not the same as being a great detective in the real world. And there are real costs, the kind the announcement does not lead with. This is not the instant scanner you are used to. Because it reads everything and tries to prove everything, it is slow and it is heavy. One developer pointed it at a small project and watched it run for nearly an hour, spinning up multiple workers in parallel before it drained half of his weekly usage allowance and then died. There is another catch hiding in the words open source. The wrapper is open, the command line tool, the instructions, the scaffolding, all of it public and free to read. But the brain, the actual model doing the reasoning, is closed, hosted on OpenAI servers, and you have to log in to use it. You cannot run this on your own machine, offline, on hardware you control. The recipe is open. The chef works for OpenAI. And now the honest limit that the marketing will never put on a slide. A tool that reads every line of a codebase to find the ways it can be broken is, described exactly, a tool for finding the ways a codebase can be broken. There is nothing in it that only works for the defender. The same agent that hunts vulnerabilities in your code so you can fix them can hunt vulnerabilities in someone else's, so an attacker can use them. This is why OpenAI keeps the most powerful versions behind a gated access program and calls the whole thing Defender First, not because the technology has a side, but because it does not. This is also why the slop paradox from the opening never fully closes. The same capability that can now write a careful, validated, high-confidence bug report can, at scale, write 1,000 plausible ones. Whether this class of tool ends the flood or feeds it is not settled, and anyone who tells you it is settled is selling you something. So step back. In the space of about a year, 3 of the largest AI labs each fielded a tool of this same shape, an agent that reads code to find its flaws. That convergence is the real signal. The security scanner is quietly changing from a machine that pattern matches to a machine that reasons, from one that asks, did the data reach the door, to one that asks, is the lock actually real? It is genuinely more capable, and genuinely not yet trustworthy on its own, which is why every serious version keeps a human at the end, judging everything the machine hands over. That tension, more powerful and less trustworthy at the same time, is the whole story of this moment in AI, and it is what we take apart on this channel, from the ground up. Our last video on security, the full free course, and the practical season are linked below. Subscribe, and when a machine that reads your code gets its next upgrade, we will read it with you.